is a unit entitled, like, How to Stay Out of Jail, right? It's all about, like, the legal system and everything else. But what he's doing is if students didn't do their homework, they're going to get put in jail and they're going to have lunch detention. Because we're getting real tired of kids just not doing what they're supposed to do. So if that's you, you might need to take a page out of my playbook and skip whatever fun thing you might do tonight and do your homework. Like, real story, I'm not going to game night tonight because I have a goal with my grad school stuff to be done with this paper by tomorrow, and I need to sit at home and do work.
I also have the same type of situation for grad school. I have homework too,
So some of you need to just like step it up and hold yourself accountable. But when you don't, then we have to. So if 332 is not done, you need to make a note to yourself and get it done tonight, or you're messing it up not just for you, but for the entire class for this homework competition. Questions on 332, and I'm concerned that we don't have questions because we're not done with it. Any questions on 332? Otherwise, I'm recording. You can go back to the video, and the answer key is on Schoology, so we don't need to sit here and stare at this. You can check answers on your own. Any questions? Yep, 332. Because this is due tomorrow. 333, I don't even know if we'll check tomorrow because I kind of want to spend all the time we can on Jenga. Because Jenga's fun. So the problem that we're hitting is when people don't do what they're supposed to do, it impacts those fun things. So if we start playing Jenga tomorrow and people don't know what they're doing, it means you haven't done your practice work seriously. It's like, we'll see what happens. We're going to start Jenga today. But all right, if there's no questions, we're just going to move on so we can finish the lesson and get on with Jenga. Addie?
Are we getting any more practice work?
Nope, this is it.
Oh.
Yep, this is, so if you want to, if your 332 is done and you're ready to go, like these homework assignments, that's what needs turned in tomorrow. You can turn that in today. Like, as long as you're turning in everything that needs turned in, you can turn it in today. 333, you do not need to turn in this week. We'll collect that next week. I'll give you guys like some bonus time on that. You can if you want. Yeah. Oh, hey. So this isn't really homework if we get it done in class. But what's going to determine if we get it done in class? Well, how much time we get to spend on Jenga. What's going to determine that? How quickly we can get through the lesson, and just how seriously you guys like take, okay, let's solve this problem and then move on. And let's solve this problem and move on. All right, so from yesterday, we had done, oh, this is 1B. Sorry, let me go back to 1A. You guys made it further than 1B yesterday. So this was your slide from 115, right? So you probably have some of this work written on your graph paper. You either need out a new piece of graph paper or yesterday's graph paper. Remember, we always need graph paper out. Right, Raphael? Every day? Always need graph paper?
All the time.
And I'm actually going to copy this and clear it so we got some space to write. So we talked about A and being able to solve that in two different ways. And actually, there's probably more than two different ways. So now let's look at B. So we're looking specifically at B. So copy this down in your graph paper because you probably haven't. And this lesson was long enough, or the homework was long enough, I didn't get this on your homework paper. Oh, I did that. So instead of saying and writing minus, what could I say and or write instead? What? Yeah, but what negative? Well, plus the negative, right? So plus the -2. You're absolutely right. I'm actually going to change this because it's bigger than I want it to be. All right, 2 plus -2. What's this dot tell us? Multiplication. Now, if I use parentheses, do I have to put the dot? No. That would be extra. Instead of putting -4, yeah, plus a -4. Instead of putting -2, plus a -2, and number up against parentheses, multiplication, right? Or parentheses against a parentheses. Guys, if you're not writing this down, you're cheating yourself. You're not cheating me, you're cheating yourself out of the chance to like practice and do this on your own. try this. Watch out for the trap doors. Remember to pay attention to signs. Remember order of operations tells us multiply first. Take at least like a minute. Talk with your partners about this. There might, hint, might be problems like this on the Jenga. Sorry, something stuck in my throat. Yeah. So there's two different multiplications.
Interruption. Z Harris, please come to the office. Z, please come to the office.
Guys, when you're setting one of these problems up, if you're right at the bottom of your paper, that's probably not enough space. So I know I said you could use yesterday's graph paper, but like if you're out of space, get a new paper. Alright, we're gonna do my favorite way to do cards. Break up the problem a piece at a time. So Moss, what did you do first here? That's fine. What'd you do first?
I did the multiplication.
Yeah, because the parentheses step doesn't really count when there's nothing to do in parentheses. So yes, we have parentheses, but they're really multiplication. So 2 drops down. What was negative 2 times 3? Negative 6. Negative 4 drops down. And then negative 2 times negative 2? Positive 8, right? Check your work at that step. What?
You said negative 2 times negative 2. You said negative 2 times.
You are correct. I misspeak sometimes because I'm not a robot.
Thank you for not being a robot.
Thank you for believing me that I'm not a robot.
Wow.
Margot, funny enough, your card is actually next. What do we do now?
I teamed up the negatives
And when we team up the negative and positives and actually like move the 8 to come over here with the good guy team, or we could have moved the 2, or what property is that lets us move? Associative was the parenthesis. Commutative. Guys, make a note here. This is the commutative property that lets us move numbers around. And guys, a lot of you just do it in your head. And that's fine, actually. But that's what lets you do it in your head is, oh yeah, I can move the 8 with the 2, and then I can make 10.
How do you spell commutative?
Here, I'll write out the whole thing. It starts with commute.
There we go. We're using short roots.
Ooh, but not for associative, though, because that would be dangerous if we shorten that one
We
down.
don't want to shorten that.
So, C-O-M. There you go. Commutative. Now, really, we never write out the entire word property in math. We almost always abbreviate it as property. So then 10 plus negative. Uh-oh, what happens here? They cancel out and make 0. Now, if with your commutative property, you actually group up and like show the teaming, now what property is that? Associative, because I brought in parentheses, right? The associative property is about associating. It's about grouping, associating. Let's associate with each other. Like when we go to Jenga and we associate you guys by teams. And it's kind of like putting you in a group with parentheses. All right, last thing to do. So Maria and George were solving this problem, and George looked at it like this one right here. So just give your eyes up here if you would, please. And George says, you know, it'd be a whole lot easier if I just do this times this first. Why? Who can tell me why George said, you know, if I just multiply those first, Maddie?
Because they came up and then they turned into a whole number, I believe.
A whole what?
Whole fraction. Like, not a whole fraction. Positive.
Positive what?
Fraction.
Margo, you want to tag in?
Since they're it will equal 1 since they times they'll both equal the same thing.
They're reciprocals! Right? When you flip the fraction over, they're reciprocals. Those make 1. So, like, Jana solved it this way, and like, she's right, but George is like, if I put these together, they actually just make one, so that'd be a whole lot easier. And here's the really cool I just broke my computer. Watch. Write this down. -9. And actually, let's just go ahead and make it a fraction. How do I make -9 a fraction?
Just add a 1 behind it.
Ooh, careful saying add, just because that's a math word. Put it over a 1, put a 1 under it, right? Like, times 1 over 9 times 3 over 8. Guys, what this really turns into is 9.
Was the second fraction negative as well, or no?
No. Good question. Great question. What this really turns into, look up here real quick, because I got some people that I think you're going to miss it, and this is sweet. Guys, this is one giant fraction. It's really -9 times 1 times 3. 1 times 9 times 8. Like, I'm allowed, that's what it turns into, right? It's going to turn into one fraction. Can I move numbers around in multiplication? Yeah, it stays the same. So could I move this 9 really like over here? Yep. So what if I do that, and I have 9 over here and 1 right here? What happens with a 9 over a 9? Oh, that's really just a 1. Or really up here, what we could have done, because we know that we're allowed to change order, we could have said, oh hey, you and you work nicely together, you both become 1s.
And then the 2 1s.
And the 1s are just 1s. So our answer ends up being
Wait, what did
-3/8. Because that negative was still there, right? It didn't cancel out with anything. Try at least the second one here, because I don't know if I have enough board space even to write the other one. Yes. Let's try another one. Stick with me. Let's try another one. If you're confused right now, that's like probably on purpose. That's a good thing. Confusion is not bad. Turn to your neighbors and talk about what of these numbers might work well together. And guys, you could rewrite it as still 3 fractions. You don't have to put it all together, but you can like move numbers around as long as what's in the numerator stays in the numerator. What's in the denominator stays in the denominator. I bet some of these numbers look like they get along real nice. Take a moment to think before you write this down. Oh, you mean like the 12 turns? Yeah, as long as these are 1s, right? So we need to make sure that we mark those as 1s.
There you are.
Divide by 4, divide by 4, right? We use reduce out by 4s. That's how they do it. 3 nines. 3 over 9 will reduce to 1 over 3. Right? So those are 1s. We just go straight through top, straight through bottom. 4. I realize the Jenga tower is in the way for some of us. So, June, at the giant party table, can you tell me like a number on top and a number on bottom here that can work well together? A number on top and a number on bottom that can work well together. 3 and 9 would be a great pairing, because that will reduce nicely. So we got the 3 and we got the 9. Destiny, can you give me another combination of numbers, top and bottom, that work well together? 4 and 12. So we took the 4, we took the 12, and now the only ones I have left, -5 and 7. Well, guys, what does 3/9 actually reduce out to? What is 3 over 9? 1/3. This is really 1/3. And what about 4/12? Also 1/3.
They're still smaller numbers.
I mean, if you want to multiply 9 times 12 times 7, you go right ahead. I don't really want
No,
to.
that's not what I did.
And then the 5 and the 7, I don't think they... So if we multiply straight through, negative 5. If we multiply straight through, okay, 9 times 7, what is that? 60. Still not as bad as whatever the heck this would have been.
Okay, but you could have, June could have done 3 times 4, which would be 12, and then 12 would cancel out.
Ah, so if we group the 3 and the 4, Misk is arguing this is really 12,
Go together.
and 12 over 12, and that's why we ended up back at 9, because Misk might as well take my job at this point.
What if the denominator would have been 256 if we did?
All of that multiplication through, yeah, which is why we reduce it if we can, but we don't have to. You'll still get the same answer. All right, on that note, who are we missing today?
Oh wait, no,
Everyone.
We're missing me.
All right, well, as cards come up of people that were missing, tell me, okay? I'm going to stop recording because obviously I'm showing your